Okay, on to the application questions. So we talked about grade previously. Grade is just kind of the steepness of a road or steepness of a roof would be, I guess pitch is technically more correct, but it is rise over run times 100. So we have this cross section here. We want to find the grade of the road of the following cross section. So I'm going to do rise over run, which gets me 6 over 55. That gets me 0.109. And sure, I can follow the formula directly, but that's kind of dangerous to do in any math class. So instead of kind of directly just following the formula, instead I'm going to use the fact that, okay, grade's a percent, so I want to take that and convert it into a percentage. Well, I move the decimal right twice. I get 10.9%. Recall in the last lecture we saw kind of this proportion when we're dealing with percents to be able to solve very simple math questions and then kind of expanded it to a little bit more general word problems. So everything in this section, like I said, we're gonna have a lot of different disciplines that we're going into, is going to be some modification of this proportion. I'm gonna alter it slightly. Some of them are exactly the same, some are very, very close, but it all builds from that. So really, if you have a strong grasp of what happened at the end of the last lecture, this lecture will probably be, I don't want to say it's easy, but will make a lot more sense if you're able to grasp those last two questions. Okay. So if we're talking about a discount, in the very general sense, a discount is if I have a list price, let's say the cost of pants are $30, they're discounted for $5, that's going to get me this new net price. So if we're dealing with it in a proportion problem, we say, okay, my discount rate is going to be my percentage over 100. The discount is going to be the part of my list price that I'm taking away. So the list price is my base. So in this question, originally a jacket cost $28. If it is on sale for 30% off, what is the new price of the jacket? So I have my percentage rate, it's 30%. I have my cost of my jacket is 28, so that's my list price. And so I'm trying to find my discount, set this up, cross multiply. I get 100x is equal to 840, divide by 100. I get x is equal to $8.40. Now we have to pause for a second because in the last problems, once we got through all this multiplication, cross multiplication, and dividing, we were done. But here we have to say, okay, the question's asking for the new price of the jacket, so I have to take my discount away from my list price. So 28 minus 8.4 leaves me with $19.60. So this is kind of helpful if you're ever in a Target or a department store or anything like that, and they're just giving you the percentage off. You can use proportions to solve it. Yeah, it might be a little bit silly to kind of pull out a piece of paper and work it out right on the spot. But if you get really good at these proportion tricks or whatever, then you don't really need to have the pencil and paper. But that's kind of a few problems down the road type of scenario. So we have another question, and I particularly like this question. So I want you to, ideally, I mean, I can't control you and force you to do anything, but pause the lecture and really think about what this question means and how you would solve it, because there's two ways to solve it, and the way the question is phrased, they're both technically correct. So the question says, the file cabinet has 34 that costs $34 is 25%. You have a coupon that gives you an additional 10%. What is the new price? Okay, so this question I like a lot because the way it is phrased, there's technically two ways to solve this. We're given the price of a filing cabinet. We're given the fact that we have a discount on it, and then on top of that, we have a coupon. So, what I would like you to do, and obviously I can't control what you're doing, I would like you to like pause it and think about what that question would mean. Does that mean that I would have a total discount of 35%, or does that mean I take 25%, find that new amount, and I get a 10% discount? Because like I said, those are both pretty much what is being said in this question, but one of them is how it really occurs in the real world. Like if you went to Kohl's, one of my students who worked at Kohl's was able to immediately answer what they do. Whether or not they do the 35% in bulk or whether they go piece by piece. And so let's just go ahead and start working through the problem. So we're gonna do the option that says, okay, I want to find 25% of 34, find that discount, and then take an additional 10% off. So I know that my original cost, my list price is 34. I know that my percentage is 25%. I cross multiply, and I get that my discount would be $8.50. So now my new list price is going to be $25.50. And now I repeat, I'm going to find what it is 10% of that now discounted list price. So now I kind of have to update my proportion. And so my new list price is 25.5, so that's going to be on the bottom left. And then my 10% discount is going to go on the top right. So I cross multiply, I get 100x is equal to 2550. I divide by 100 and I get 2.55. And now I'm going to subtract that from the new list price again. So I will get 22.95. And so sure, if you worked out the 35% thing, it's going to be nicer because there's only one step. You're not repeating a process or anything like that. But the truth of the matter is that if you are going to Kohl's, they're doing this two-step process. Because if you take that 35% bulk from the original price, you're going to get a lower cost, which Kohl's doesn't really want you to do. So they're going to, and any retailer, I don't know, I'm focusing on Kohl's, I guess, because that's what my student worked at. But any retailer does this, is they take the piece, they take the first percentage, take that away, and take the second percentage and remove it in a second step, because that gets you a higher overall price. Which makes sense because when you reset that list price, you are taking a smaller percentage away. Okay, that was a lot of talking. On to sales tax. So sales tax looks very similar to the discounted price because that's exactly what we're doing. We're taking the list price, we're taking a tax rate, which is going to be a percentage. That's going to figure out our sales tax, and then to figure out the total cost instead of subtracting it from the price, which would be nice when things are on sale. It's a tax, so we're actually going to have to pay more money. So I think this example is close to correct. I don't think technically the sales tax overall in Colorado is 7%, but I think that is the base level. And then kind of depending on where you live, it's going to be another 2, 3, 5% or whatever. So the base level is 7%. Let's say a pair of pants costs $68. What is going to be the total cost? Well, go ahead and set up a proportion. List price is 68, tax rate is 7. Cross multiply, I get 100, x is equal to 476, divide by 100, I get x is equal to $4.76. So I take that, I add it to my list price of $68, and I get that my total price is 72.26. And this is something that, yeah, maybe you might not be able to figure out that exact number, but it's important to be aware of like a ballpark of, okay, I'm buying these pants that are $68. What seems like a reasonable tax? Do I need to be, am I okay walking to the register only having $70 or something like that? Okay, percent increase, decrease. And sure, those past examples are helpful, especially if you're going into something specifically that involves that, if you're going into retail, if you're going into drafting, if you're going into engines. But this one's more universal for kind of all disciplines, is percent increase and decrease. And this is something that I talked about at the beginning of the percents lecture. This is a good case when you can't kind of rely on that concept that, oh, I always need to be less than 100%. Quite often you can have percent increases that are much larger than that. And so instead of writing two formulas because they're the exact same for percent increase or decrease, this is the proportion that we would set up. We would take the amount of increase or decrease, put it over the original amount, and that would be equal to the percent increase and decrease, and we put that over 100. So a lot of words. Here's kind of to dive into an example, see what I'm talking about. So the cost of a movie ticket was originally $12.50, but it has increased by 15%. What is the new price of the ticket? So to set up the formula, my original amount is 12.5 or 12.50, and my percent increase, because the new price went up, my percent increase is 15%, so my proportion becomes x over 12.5 is equal to 15 over 100. I cross multiply, I get 100x is equal to 187.5. Divide both sides by 100. I get 1.875, which in context is important. Well, you can't really have a half of a cent, so chances are the movie ticket isn't going to be 1.875. It would go up to 1.88. And then we would have to add that to the original cost of the movie ticket, which was $12.50. So combining those two concepts, if I add 1.88 to 12.5, I will get $14.38. I should have included the symbol dollars. It was a mistake. It's a application problem, so it should be $14.38. The PSI on my car went from 35 PSI to 27 PSI, pounds per square inch, I believe. What is the percent decrease? So I want to figure out what the percentage of the amount of air has left my tires, essentially, or at least the pressure. Okay, so the amount of decrease is going to be, we have to do a little bit of work to find that. We started with 35, we went to 27, so the decrease, we subtract the 2, we get 8. And then to set up the proportion, we have the amount of decrease over the original amount, which was 35. And then we have that over the percentage x over 100. So to kind of, since we don't have the last slide right next to us, that proportion setup is we have the part or the amount that was decreased top left, which in this case was 8, the original amount on the bottom left, which in this case was 35, and then we were trying to find a percent. Cross multiply, I get 35x is equal to 800. Divide both sides by 35, I get an increase of 22.86%. And so that's important to keep in mind, is that you might have to do some work to find out the actual decrease. Don't just kind of jump in to say, okay, I have two numbers, I'm going to do the 35 on the bottom, 27 on the top. If you're dealing with percent increase, decrease, and they're not telling you what's increasing or what's decreasing, you need to find that amount yourself.